If you examine the digital learning landscape that defined the early 2020s, you find a system built for vast scale, yet experienced in total isolation. The distance learning era from 2020 to 2023 operated on a specific philosophy: maximum flexibility through asynchronous access. Institutions digitized their content, built massive repositories of recorded lectures, and relied on static discussion boards. By 2025, institutional data revealed a clear saturation point. The very flexibility that was intended to liberate learners was frequently the source of their detachment. Extensive reliance on asynchronous models emerged as a primary driver of student isolation. Without a live cadence, cognitive engagement and completion rates steadily deteriorated. Static recorded content has become a baseline commodity. Providing a digital library of lectures is no longer sufficient to differentiate the value of higher education. The response in 2026 is a deliberate shift in institutional standards toward real-time education, or RTE. RTE discards the passive repository model. Instead, it relies on high-fidelity, synchronous learning environments, structured around live data analytics and continuous in-flow interaction. With learners expecting immediate feedback and peer interaction, synchronous engagement becomes a structural requirement for the modern curriculum, moving beyond simple video delivery. Moving toward a dialogue-first model requires looking at the data separating these two modalities. Recent studies, including the 2022 G et al. Research and the 2025 Frontiers in Education report, provide a direct comparison. This grouped bar chart compares the performance of asynchronous models against synchronous environments across three specific metrics: task motivation, psychological safety, and need fulfillment. In all three categories, the synchronous model shows significantly higher results. Look closely at psychological safety. Live settings supported by private, chat-based inquiries create a protected environment for students to ask questions, removing the public vulnerability often found on legacy message boards. The same advantage appears in need fulfillment. Live, immediate environments satisfy the human psychological needs for competence and relatedness. They facilitate the peer-to-peer and instructor-to-peer connections that address the issue of physical isolation. The data suggests that human presence and synchronous interaction are the primary drivers of an academic sense of belonging, factors that static content repositories cannot replicate on their own. Scaling this real-time model, however, encounters a biological barrier: the physical limits of human attention. This is the legacy structure of a live digital classroom. It relies on a one-way flow of information from a single central node, the instructor, broadcasting outward to dozens of students. Friction occurs the moment multiple students encounter gaps in understanding during that live broadcast. The bottleneck is immediate. If the instructor stops to address one misunderstanding, the primary flow of information halts for everyone else. Delivering individualized, real-time feedback to 50 students simultaneously is difficult to achieve without depleting the instructor's cognitive bandwidth. Therefore, scaling real-time education cannot rely on human labor alone. It requires an automated intermediary capable of handling micro-corrections without pausing the class. The catalyst for this scaling is the integration of Agentic AI. It operates independently in the background, analyzing data streams without waiting for manual prompts. These algorithms integrate into the live environment, performing adaptive testing in flow as the lecture happens. This creates short-cycle feedback, immediate corrective interventions that occur in the exact moment a concept is misunderstood. When we apply this AI layer to the live classroom model, the architecture changes. The moment a student falls behind, the AI identifies the gap and intercepts the issue locally. The instructor continues the lesson. The AI generates specific, explanatory feedback, resolving the misunderstanding directly with the student. Agentic AI decouples individualized remediation from the primary delivery of the lesson, expanding the instructor's reach without increasing their cognitive load. Transitioning to this model at an institutional level introduces operational frictions that require active mitigation. One threat to academic quality is cognitive overload, commonly experienced as Zoom fatigue. Continuous screen saturation drains student endurance and reduces the mental space required for deep reflection. The mitigation strategy requires strict formatting. Institutions should enforce micro-live sessions, capping continuous synchronous dialogue at 15 to 20-minute intervals before shifting activities. The second friction is the digital divide 2.0. Real-time, high-fidelity video demands high bandwidth. Mandating it uniformly will exclude rural and lower-income students lacking stable infrastructure. To maintain baseline equity, systems must deploy low-bandwidth, chat-first options alongside hybrid analog tools. Finally, academic integrity. Traditional proctoring and massive exams fail to address the needs of fluid, live digital settings. Assessment should shift toward process-based tracking and immediate in-session oral knowledge checks. Without these specific operational policies, an RTE rollout risks replacing the isolation of asynchronous learning with the cognitive exhaustion and technical inequity of synchronous learning. Establishing an RTE framework requires institutional leadership to formalize 3 pillars of infrastructure. First, institutions must shift away from proprietary, siloed software. The architecture must be an interoperable ecosystem where live video, collaborative whiteboards, and real-time data layers share a unified boundary. Second, as AI acts autonomously, institutions must establish strict AI ethics and governance policies. Learners require transparency. They must always know whether they are interacting with an AI tutor or a human facilitator. Third, the instructor's primary function shifts toward live facilitation, a departure from the production-heavy focus of previous distance models. Workload models require an update to prioritize active, live engagement hours over the production of static content. Real-time education is a renegotiation of an institution's technological architecture and human resources. Real-time education addresses the tension between the convenience of digital access and the necessity of human connection. By enforcing dialogue and continuous interaction, we are returning to the oldest models of learning. We are utilizing the technology of the 21st century to reinstate the Socratic roots of academia. This pedagogical shift also serves a highly critical administrative function for modern institutions, issuing verifiable proof of capability. Aligning RTE's real-time competency tracking with digital micro-credentials generates tangible value for the modern skills economy. For higher education institutions, the ability to master and validate the live experience represents a primary path to maintaining relevance in an increasingly automated skills economy.